In this video, I will discuss about the National Ambient Air Quality Index. Air Quality Index is a tool for effective communication of air quality status to people in terms which are very easy to understand. It transforms complex air quality data of various pollutants into a single number, nomenclature, and color. There are six air quality index categories, namely good, satisfactory, moderately polluted, poor, very poor, and severe. Each of these categories is decided based on ambient concentration values of air pollutant and their likely health impacts known as health breakpoints. Air quality subindex and health breakpoints are evolved for 8 pollutants: PM10, PM2.5, sulfur dioxide, nitrogen dioxide, carbon monoxide, ozone, ammonia, and lead, for which short term up to 24 hours time weighted average national ambient air quality standards are prescribed. Based on the measured ambient concentration of pollutants, sub-index are calculated. Measured ambient concentration sub-index is calculated, which is a linear function of concentration, and the oath sub-index determines the overall air quality index. Let's see the short-term national ambient air quality standards for 8 pollutants. For sulfur dioxide and nitrogen dioxide, it is 80 microgram per meter cube. Particulate matter 10 is 100 microgram per meter cube. PM 2.5 60 microgram per meter cube. Ammonia 100 microgram per meter cube. Lead 1 microgram per meter cube. And this is that 24 hours time weighted average. And for ozone and carbon monoxide, it is 8 hours time weighted average. Ozone is 100 microgram per meter cube, carbon monoxide is 2 milligram per meter cube. Before going to see the health breakpoints for each 8 pollutants individually and for overall air quality index, we would like to know what is breakpoints. Breakpoints refer to the pollutant specific ambient air concentration ranges and associated potential health impacts. Concentration ranges of each pollutant is represented through a segmented linear or a non-linear function. So here you can see that the percentage of carboxyhemoglobin in blood and respective symptoms is given, and we know that the affinity of hemoglobin for carbon monoxide is 200 to 250 times than that of oxygen, and for concentration of 10 milligram per meter cube, percentage of carboxyhemoglobin is hemoglobin level could be about 2%. This may be just the beginning of slight effect to people, affect the people having lung or heart disease. So this is a 2% is 10. So here it may be the moderate range. So from 2 to 10, you can see this is the moderate. So 2 microgram to 10 is moderate, and 0.1 is good, and 1.1 to 2 is satisfactory. Likewise, you can see that for PM10 the maximum permissible limit is 100. So 0 to 50 good, 51 to 100 is satisfactory, and accordingly moderate, poor, very poor, and severe is calculated for each for breakpoints in a scale of 0 to 500 for the for each air pollutant. But this chart is different in different countries because of their ambient air quality standards. CPCB reviews these air quality breakpoints every 3 years after accounting the new research finding on air pollution, exposure and health effects. This is the health statement for ambient air quality categories. The good, which is 0 to 50, is have minimal impact. 51 to 100 is satisfactory, may cause minor breathing discomfort to sensitive people. Moderate, which is 101 to 200, may cause breathing comfort to the people with lung disease such as asthma, and discomfort to people with heart disease, children and older adult. Poor is 201 to 300, may cause breathing discomfort to people on prolonged exposure and discomfort to people with heart disease with short exposure. Very poor may cause respiratory illness to the people on prolonged exposure. Effect may be more prolonged in people with lung and health disease. And severe, which is 401 to 500, may cause respiratory effects uh, even on healthy people, and serious health impacts of people with lung and heart disease. These health impacts may be experienced even during light physical activities. And this color code is also important. For good, it is deep green, satisfactory, light green, moderate yellow, poor orange, very poor red, and severe is deep red. So how we calculate sub-index? Sub-index is a linear function, linear, nonlinear, segmental linear of measured ambient concentration of pollutant, and it represents relationship between pollutant concentration and corresponding sub-index I. Typically it is Ix relationship, so it's a straight line. I is equal to alpha x plus beta. Alpha is the slope and beta is the intercept at x is equal to 0. So the general equation for the sub-index for given pollution concentration Cp as based a linear segmented principle is calculated. Here you can see that sub-index II is equal to I high minus I low divided by B high minus B low into Cp minus B low plus L low. And B high is breakup point concentration greater or equal to the given concentration. B low breakup point concentration smaller or equal to the given concentration. I high is ambient air index value corresponding to B high. I low is ambient air quality value corresponding to B low, and Cp is the pollution concentration. So we see the example. Suppose PM2, PM10 ambient concentration is 85, that is Cp is 85. Calculate the sub-index for PM10 if B high is 100, B low is 50 microgram per meter cube, and I high is 100 microgram per meter cube and B low is 50. So by applying this formula, we get that the sub-index air quality sub-index for PM10 is 85. Similarly, sub-index can be calculated for other pollutants as well. Now determine the overall ambient air quality standards. India or CPCB adopted maximum operation system for determining the overall air quality indices, which means that out of this 8 pollutant, which individual sub-index is great maximum, that will be the air quality index, overall air quality index. And the reason behind for adopting this is free from eclipsing and ambiguity, and health effects of combined pollutants. The synergistic effects are not known, and thus a health based index cannot be combined or weighted. So what is ambiguity? Ambiguity occurs when uh, an air pollution index gives a false alarm even though the concentration of all pollutants are within the permissible limits. So ambiguity overestimates the pollution level. So let the overall pollution level I is like this. I is equal to I1 plus I2. The sub-index 1 and sub-index 2, sum of this is the overall index. Then if I1 and I2 is less than 100, which indicates that the concentration of each pollutant is within the permissible limit. Now if I1 is 70, say here, and I2 is also 70, so this total I would be 140, which indicates that pollution standards are violated. So, but actually both are within the limit. So it overestimates the uh, pollution level. So this is called ambiguity. But left it is the half of I1 and I2. So, and if I2 is 60, let's say this, and I1 is 120, likewise. So you can see that overall I would be 90. 60 plus 120 is 180 and divided by 2 is 90. So though the standards are violated for I2, so the standards are violated for I1 actually. I1, then I can say that the combined index underestimates the pollution. So eclipsing occurs when air pollution index does not indicate poor quality even though concentration of one or more pollutants are very high. So it underestimates the pollution status. Now the interpretation of air quality using IND, India Air Quality Index. So this is our legend we have already discussed, and this is one of the some of the examples. You can see that the sub index are given here for various pollutants, and you can see here that the maximum pollutants is PM 2.5 is maximum sub index value is PM 2.90, and the overall quality is 93. Accordingly, you can see that the maximum value is here, and the maximum value is here, and this is. So based on the overall quality of the standards, based on the maximum of individual pollutant standards, which will be the ultimate overall air quality index. So this is a calculator. You can see, you can say the dates or station, city or state from where the air quality index is given, and this is our pollutants is written, and its concentration is microgram per meter cube except for carbon monoxide, which is milligram per meter cube, and at least 3 inputs is given to run this calculator. So I put values accordingly, and when I put values for PM10 is 125 microgram per meter cube, the sub index is calculated, and the sub index is 117. and the checks shows that it's 1. Checks means if the value is greater than 1, then it shows 1, otherwise it will show 0. So if I put sulfur dioxide 0, so you can see that checks is 0. So accordingly I now put values and sub index is calculated. And you can see that the sub-index value is maximum for PM10 117 and air quality index is shows that 117, that is moderate, and the color is yellow. If I change PM10 to 250, that it becomes the sub-index value becomes 200 and air quality is within the range of poor. So accordingly you can calculate the air quality index by using this calculator. So I just remove some of the data because I'm going to show you that I need at least 3 inputs. So I remove all 4 inputs and only PM10 2.5 in NOx is there. You can see that the air quality index is calculated. Now if I remove one more PM 2.5, so you can see that it shows that at least 3 inputs is required. So if I put another inputs, you can see the air quality index. But what I'm going to show you that if I remove PM10 and put another ozone, that is at least 3 inputs is here given, but there is no result because out of 3 inputs, you know, one should be PM10 or PM 2.5. Now the conclusion is because of its single number, nomenclature and color code, air quality index can be easily interpreted by common man. Air quality index is also helps in easy understanding of air pollution level in real time. Higher air quality index number indicates a higher health risk. Air quality index support decision making process related to air pollution mitigation measures. So you can read these references, visit the CPCB sites. Thank you for watching this video.